Hello everyone, my name is Holiday. Today we want to talk about mathematics, advanced mathematics, and we'll be looking at ellipse, which is a part of conic section. Now, number one thing you must know about ellipse is that an ellipse is what? It's a set of all numbers, or set of all numbers, or set of all points on the ellipse, such that this point is what? Having a what? A distance from what we call the focus. Let's call this focus plus or minus c. Let's say it lies on the x-axis. Let's call this an x1 comma y1. Now this place is not origin, but this point is x1 comma y1 because the focus lies on that one. We have another one here. Let's call this one minus because here is negative x. And let's call this one. Let's have another focus here. Let's call this an f2. Let's call this one plus s1 y1 comma. Now if you have the focus, let's call this one the vertex. This one will be minus a. Let's call this one minus a, the vertex, minus a plus x1 comma y1, and we explain x1 and we explain a. Let's call this one v, one of the major vertices, which is, well, let's call it plus a x1 y1. Now having understand that, now what we need to do now is that there is another minor vertex here, because these ones are major vertex. This one here, they are minor vertex. We can call them, this one is plus b x1 y1. x1 y1 are center of the ellipse. So this one is what? Minus b plus x1 y1. I will tell you why I'm adding them to x1. Let's just take it diagram first. Number one thing I want to explain first is that an ellipse is what? Is a conic section with an eccentricity less than 1. So the eccentricity of an ellipse is less than 1. What is an eccentricity? What is the meaning of eccentricity? Now eccentricity is the ratio. Eccentricity is the ratio of the focus to the ratio of directrix, meaning that the distance between the point on the ellipse to the focus divide by the distance between the points to the directrix. Don't forget the directrix will always be here. They will always be here. They have a directrix here. And now that means that the distance from the point to the directrix must be what? Greater than the distance to the from the point to the focus. That means eccentricity is the ratio of the length of focus over the length of directrix. That is eccentricity. That is ratio. Now, but what do we mean by eccentricity less than 1? That will not define that word. So when I say ellipse is the set of all points s, y, which is 4 points here. All these ones are points on what? On the ellipse. They are all points on the ellipse. Now what is it? How do you draw? Because this eccentricity is what we use even in drawing to draw what? Ellipse, to form that shape. Now what he's saying is that a set of all points such that the distance of the points, or the distance between, let me put it that way, between the points and the focus or a fixed point, don't forget focus is called fixed point, is less than the distance between the points and a fixed line. Now this fixed point is what we call the focus, while the fixed line is what we call the directrix. Don't forget, we call this one directrix. That's what we call the fixed line. Now these fixed lines are vertical line, while the focus is inside the ellipse, which we use to analyze the shape of the coordinate section. Now, most importantly, because in this analysis I'll be more precise. I don't want to talk about how to derive, but I'll be more precise. Now, we have talked about the length of focus less than the length of directrix. That is why the eccentricity is always less than 1. According to our definition, is less than 1. Now, another vital point I should tell you is that the equation of ellipse is defined as x minus x1 all square over a square plus y minus y1 all square over b square equal to 1. Now let me define the parameter very well. A is what we call the major axis. And the major axis here lies along the x-axis. How do I know? If you check the x is coordinate is on top of A. So A is along the x-axis. If I bring this one here and bring this one here, that means A major axis will not be along the y-axis. The diagram will be different. But from what we are seeing in the diagram, you can check. That means from here, what we are saying, from here to this place is A, and from here to this place is A plus X. Here, from here to here is A plus X1. From here to here is A plus X1 from here, A plus X1. In magnitude, they are the same in terms of magnitude, but one on the negative x-axis, one on the positive x-axis. But what we are concerned about now is to give you a breakdown definition. What about B? B is what we call the minor axis. Please don't forget minor axis. Then won't forget again that the length of the major axis. Length of major axis is defined as as 2a. And this 2a, from the derivation, we see that it is the sum of distance from here plus here. The distance, we calculate the distance between these 2 points and the distance between these 2 points and take add it together. When you add it together, equate it to be equal to 2a, you are going to derive this equation. So it's a very long method anyway. Now we go again. What about the length of the minor axis? They can ask you which are the important points is equal to 2b. Length of minor axis. And don't forget, A is always greater than B. So that is to say, because in the question, they might not name it alphabetically. Just check. For instance, if I give you 2, let's say x minus 2 all square all over 16 plus y minus 3 all square all over 25 equal to 1. In this case now, how do you know it's an ellipse first? Number one, this one may be plus, this may be plus. If it's minus, then become an hyperbola. So this is an ellipse, you add a plus sign. Number two, and which one is major? Now looking at 16 16 is same thing as 4 square for what we are looking to compare, while this one is for 5 square. And that means 5 square is bigger than 4 square. That means your A would be equal to what? 5. Since 5 square is greater than 4 square. So it's not necessarily that the first thing that we see must be major. No, it is the bigger denominator, the bigger numbers of the denominator becomes the major. Like what I told you now, 16 and 25. 25 is major. Forget about the arrangement. Just pick. That's why I make emphasis on this for us to comprehend. Now, the next thing to know is that there is a center here. The center of what? Of the ellipse. The center of the ellipse is equal to what? S1, Y1. In this case, I'm looking at what? This is the center of the ellipse. So we can always bring it out from the equation. That is the center of the ellipse. So having known the center of the ellipse, now don't forget I told you that what? The major lies are what? Along the what? The x-axis. Along the x-axis. And don't forget, the x-axis and the y-axis are symmetrical. They are axis of symmetry. Why? They divide the, if you look at this x-axis, it cut this one and this one into 2 equal half. That's what we mean by symmetry. Then the y also cut this part and this part into 2. So it's their axis of symmetry. Axis of symmetry. We call it axis of symmetry. So you write it down. Now, what we are now saying now is that since major lies along the x-axis, that's why our focus coordinate, the coordinate of the focus is equal to what? We now have what? Plus minus c plus s1 y1, which is the foci. I want to give the foci. This one is f1, and what? f2 will now be equals to what? Plus c of x1 y1. Why are we adding the c to x? Because the major lie along the x-axis. If it lies along the y-axis, we have added this c to y-axis. And why is one taking minus, one taking plus? Because there are two foci, f1 and f2. There are two foci. So automatically it means that, in fact, sometimes we write it what? Like this. They will say, in other words, you can write it like this. In other words, it can be written as f equal to plus or minus c s1 comma y1. They write it like this. You write plus or minus plus or minus c plus x1 comma y1. This y1. So now that is what some textbook write, but I think I'm breaking it down there. What about the vertex coordinate? The vertex coordinate is equal to, that means the vertex. Although we have the major vertex, which is this and this, and we have the minor vertex, which is this and this. But most books don't focus on minor, they focus on major. So I will advise we go for major. Now the major vertex, let's say v1 is equals to what? Minus a plus x1 y1, because it lies on the what? x-axis. You see that we are adding our a to the x, comma v2 becomes what? Plus a x1 comma y1. So that is what? This one we call the major vertex. So what about the minor ones? The minor one, if they ask you, let's say v3, let's call this one v3, becomes what? Plus b. It will not be minor axis that you add to what? Minor vertex along the x, because it lies on the x. What about v4? v4 becomes what? Minus, this one is v4, minus b plus x1 y1. So that becomes your vertex coordinate. Then another thing again we need to comprehend here is that what is the relationship between, there's what we call c. C is called the focus. C is called the focus axis or the focus. Now this focus have a relationship with your major and minor. It has a relationship with your major and minor, and the focus, which is all square, should be equal to major square minus minor square, minor axis square. Now this is major. Now why am I giving you this formula? In fact, this is what makes an ellipse less than one. Now look at it. What I'm saying now is that the eccentricity of an ellipse. That's why look at it. C square equal to what? A square minus B square. That is the formula for what? So if they ask what we give what, maybe sometimes you want to find major and you know your minor, you have your focus, then it is very easy. Don't forget, recall, if you don't know it now. C equal to what? A times eccentricity. So C is what? Is the product of the major times eccentricity. So the focus divided by major will give us eccentricity. That is another definition of eccentricity again. The focus divided by what? Major axis will give us what? Eccentricity. Now let's go. I hope you are enjoying the class. What you're going to do now, since C is equal to AE, let's substitute in place of C, let's put AE. AE all square is equal to A square minus B square. So that means sometimes they give us eccentricity and they give us major axis. You can find your C. It's very easy. So divide both sides by what? Just say this one is written as square, A square, E square equal to what? A square minus B square. What do we have now? Divide both sides by A square. If you divide both sides by A square, what do we have? We are going to have this one will cancel this. We have E square equal to what? A square over A square minus B square over B square. Recall that what? A plus B over C is equal as A plus B over C is equal to the same thing as what? If you remember our O level got to B over C. So that means that this C will divide this one plus B divided by this. So similarly, A square divided by A square, then B square divided by A square. So this one is A square. Now what do we do now? This one will cancel out. We have E square equal to 1 minus B square over A square. So eccentricity now has a formula in ellipse that is equal to 1 minus what? B square over A square. Now what is the essence of this formula? In case you are giving a word major and minor, in fact you can even be giving a word an ellipse equation. From the ellipse equation you can bring your A out, you can bring your B out, then put them inside it and get your eccentricity. Because it's possible that they give you an equation like this. Maybe they give you an equation like this. Maybe x minus 4 all square over maybe 25 plus y minus 2 all square over 16 equal to 1. I'm just being, so what you just need to do is to what your B is 4 square here, or just take your 16 here direct, then B is A is 25. You just take it, then you find your eccentricity. That is the essence of this formula. Another thing again that we need to know is what? The latus retrum. The latus retrum of the parabola, of the ellipse. So what is the latus retrum formula? So the length of latus retrum is equal to what? 2b square over a. This taking of that is 2b square over a. That is the length. It must be what? Is the length. That means it's in units. So that is the length of latus retrum. Oh, so what about the what? The equation of the directrix. Equation of the directrix. How do we get the equation of the directrix? The equation of the directrix is simply x minus s1. If it lies on the s-axis, if it lies on the y-axis, it will be y minus y1. Since it lies on the x has the x minus s1 equal to plus or minus a over a as what? This one you are going to have. Sometimes some textbook we write it as this: s equal to what? Plus or minus a over e plus s1. It's still the same thing. That is equation of the directrix. Now another thing you must note here, I want to drop some shortcut here so that we can get it. Now the center coordinate of a what? The center, I told you the center is s1 comma y1. Eh? If the center is s1 comma y1, let me drop this shortcut. Now the shortcut is the focus normally is plus or minus c plus x1 y1 focus minus, let's say the center, this focus now, the foci what coordinate. Now then we have what, center s1 y1, this center coordinate. Now if you now subtract it, what you are going to have is what? You are going to have what? Plus or minus c comma 0. And if you take the magnitude of this one, what you are going to have is c. So that is to say, when you subtract the center from a foci, what your foci coordinate or focus coordinate, as the case may be, you are going to have a what? A focus as what? As the answer. So a foci coordinate minus subtracted from the what? Center coordinate will give us a focus. Similarly, this is a powerful shortcut that you must take note of. There is what? A vertex coordinate, vertex coordinate minus the center coordinate. Center coordinate will give us what? The major. Now the major axis. How? Plus or minus a plus x1 comma y1 minus s1 comma y1 will give us plus or minus a comma 0. Let's subtract. You understand? This one minus this. Do you know it will cancel out this one? Then it will not remain this. Then y1 minus y1 will give us 0. Then when you take what my Pythagoras theorem of this one absolute, I want to have c. Similarly, when you have what? Vertex coordinate minus center coordinate, that means a plus or minus a plus x1 y1 minus s1 y1. So what we are going to have is that this one will be subtracting this one. So what we have now is what? Plus or minus s1 minus s1. The equation will cancel this one. You have this one. Then y1 minus y1 will get 0. Then when you take absolute, you have a. So it has been concluded now how the shortcut works. So we can now go on to solve question. But basically, I've given you all the things you need to understand this ellipse. So I believe with this understanding, in our next videos, we'll be showing you how to apply them to solve questions. Don't forget that you can also what? Differentiate. Let's say you have what? Something like this now. Let me just take a simple example of an ellipse that have a center of 0. Let's say a square over x square over a square plus y square over b square equal to 1. This is an ellipse that what? That have a center of 0 comma 0. Now if you want you to find, maybe this will find the equation of the line tangent to this word. First of all, you must learn how to differentiate. What you just need to do is simply differentiate it. And how do you differentiate? First of all, turn it to a linear format. Multiply all through by what? A square b square. That's multiply all through. If you multiply this one by a square b square, you have what? B square s square. Multiply this one by a square b square. This one will cancel this one. Then we have a square y square. Multiply this one by a square b square. We will have what? A square b square. After you have turned it to something like this, you now differentiate it to get your gradient. So what do you have now? You have 2. If you differentiate with respect to s, 2 multiplied by 1, we have 2. Remove 1 for here. We have 2b square s plus. Differentiate one now. We are going to use implicit what? Differentiation. So when you differentiate y, you are going to attach the y over the x to it. So we are going to multiply it. We have 2a square y, the y over the x. Don't forget y is a dependent variable. And when you differentiate this one give us 0. So when you solve it, make y the y over the x solve the formula, which is gradient. Take this one the other side. I have 2a square y, the y over the x give us what? Minus 2b square s. Now when you divide both sides by what? Divide both sides by 2 what? A square y. 2a square y. What I want to have is this one will cancel this one, then the gradient m becomes what? This one cancel this one, if I cancel this one, you have b square minus here over a square y. Now this is the gradient of this part, what? Ellipse. Therefore, if you want to now find the equation of tangent to the ellipse is equals to what? Y minus y1 into bracket what? M equal to m open bracket s minus s1. So you put this equation here. Then what about if you want to find the equation of normal? So what you just need to do is just to find, don't forget, if tangent is equal to n, normal will now be equal to what? 1 over minus n. That means if normal will now be 1 over negative tangent. So in that case, you just do y minus y1 into bracket what? 1 over minus m s minus s1. Don't forget your equation, your gradient. This is gradient or slope, gradient of the ellipse. So that is gradient of the ellipse. So you just put it there. As you get the gradient of the ellipse, put it in your, to get your tangent, put it what? They must give you points x1 and y1. Because the what? S1 and y1 are the points. They will tell you this ellipse, they will tell you it passes through x1 and y1. So those points that it passes through are those reference points that we want to. Why these ones are arbitrary points on the what? On the ellipse. Arbitrary point. They are arbitrary points. They are points that make up the shape or the loci for the points of the ellipse. I believe you have enjoyed the class. God bless you. My name is Engineer Holiday. Ensure you follow and subscribe. Press the notification button to get more. Thank you.